names, let's get the names of the rules in order with how they are in your notes. So Shelby, can you give me the first one? Yep, off, oh my goodness, principle. So that's the first one. Ooh, that is bad. It's supposed to be focusing. There we go. Thank you. First and thoughts. Especially the Yep. All right, what's the second one, Wes? Okay. Polly. Polly exclusion principle. Who's got number 3? Oh, Hund's rule. So let's sort of talk about these and shorten them just a little bit. Rule number 1, off-ball principle, basically says the electron goes to the lowest energy level and lowest sublevel first to fill. So if I have an electron and it's picking its energy level and its sublevel, it's going to pick the lowest one first. That's basically what that means. Rule number 2, Pauli exclusion principle. Basically says no 2 electrons can fill the same position, the exact same position. Or the other way you'll see it, no 2 electrons can have the same set of 4 quantum numbers. That's the simplified version. And then the last rule Rule 3, Hund's rule, also called the sharing rule. Like when you were a little kid, I'm sure you had, I don't know, some bag of candy or something you had to share with somebody. And you would do that little thing, one for you, one for me, you know, pass them out. And everybody got a second one. That's how it is with filling the energy levels and the sublevels. Every position in the sublevel gets 1 electron before any get 2. So, let's see. Every position within an energy levels specific sublevel gets 1 electron before any get 2 electrons. And the first electron always a plus 1 half. It's always written as that up half of the arrow. It always has a value of plus 1 half. And it'll be a lot more clear after we do a couple of these with elements from the periodic table, I think. Okay, so those are the 3 rules we have to remember when we do this stuff. Now I'm going to ask you one more question. I want to see if you can do it. the quantum numbers. How many were there? 4. See how many you can write down without going back and looking at stuff. See how many you can remember the name of. See if you can remember them in order. Okay, let's write them down then. Do the best you can. First period, we got 3 out of 4. You can remember the name of the one that's the hardest to remember. See if you can beat them. Lucas says no. And we got the first one. That's the easiest one to remember, I think. Well, maybe the fourth one is. What's the fourth one? Good. Spin quantum number. Tells us which way it's moving. Good. 3 is magnetic. This is the one that's hard to remember. Woo! Good for you. Angular momentum. That tells us the shape. Ooh, what's the one that tells me the energy level called? That's the one I thought you guys would get for sure. What? Principal quantum number. Yay, Wes. Okay, so we got them all in a roundabout way. Now let's start using them. Get that little card out that we made yesterday. So we're going to use it. And we're going to do something called electron configuration notation. With all this information, and this is just a way to determine and show the rotation of electrons in an atom. So let's start easy. I'm going to show you how we set these up. This you should be able to answer without your periodic table. I'm going to pick, because it's small, I'm going to pick the element carbon to begin with. Then I would ask you, how many electrons does it have? 6. I'm going to write that down up here. And then we're going to do electron configuration notation with it. And this takes up a little space. But what we start with is we look at that card and we say, okay, where's the number 1? What does it tell me fills first? And when you look at that, you should see 1s fills first. Yes? How many positions does the S sublevel have to hold electrons? 1. So I show that position here, and then I'll ask you, Cole, how many electrons can that position hold? 2. So, do I have 2 electrons? Yes. So I'm going to go ahead and put them in like I'm supposed to. 1 at plus 1/2, 1 at minus 1/2 by their spins. Remember, they spin opposite directions. And then I'm going to come up and I'm going to take away my 2 electrons, which now gives me 4 electrons, because I have to keep track of that. And then I'm going to go back to my card, and I'm going to see what fills next, according to my arrows. 2s, good. So I write it in the same place, just above it. Down here, you guys, would be my nucleus, if I were really thinking about this. And this shows me sort of how they're moving around. So we just said S has 1 position. I go to myself, do I have 2 electrons left? Yep, I do. So I'm going to go ahead and put them in. Come up here and subtract them, which now leaves me with 2 electrons. And then I say, okay, what do I fill next? Follow your card and see if you can find it. 2p. When I write my 2p, It's a little farther from the nucleus and just a little bit above the 2s. So I go 2p. P has 3 positions. I show them with the lines. And then I say, okay, how many electrons do I need to fill this? How many electrons do I need to fill this whole sublevel? 6. Do I have 6? No, I can only use what I have. Hund's rule. Everybody gets 1 before anybody gets 2, if I have enough. So I come down here and I put my first electron in. Remember I said they're always spinning positive first. And then I come over here and I put my second electron in. And I'm done. So I can look at this and I can go, okay, if there's lots of information you can get from this. If I didn't tell you it was carbon, you could count the arrows and go, oh, it has 6 electrons. That's carbon. You could look at this and I could say to you, how many electrons are in the first energy level? You would tell me 2. Or I could say, in the S sublevel in the first energy level, how many electrons are housed? I could ask you that. I could say, how many total electrons are in the second energy level? And you would have to add them up and tell me 4. I could ask you, how many electrons would be needed in order to fill the 2p sublevels? And you would look at what you're missing, and you would go 1, 2, 3, 4. So there's all kinds of questions that can be answered using these diagrams. Now let's look at one that's a little harder. Let's look at, let me think about it for a minute. Let's try calcium. It's sort of middle of the road. How many electrons does calcium have? You should be able to know without your periodic table. 20. Okay. 20 electrons. I want to start like I started before. The first place that fills is 1s. And I have 18 electrons. Then I'm going to fill my 2s. Now I have 16 electrons. Now I'm going to go ahead and do 2p since we've already done that. Do I have enough electrons to totally fill p? Yeah, so let's do it. And now I'm down to 10 electrons. Now I want you to stop for a minute. Because we've already done this. If I stop here, well, no, we've done a little bit extra. Oh, if I were to stop here, what element would I have? Neon, yeah, because I've got 10 electrons. But I have more than that. So once I fill 2p, where do I go from there, according to your card? What's after 2p? 3s, yes. Everybody follow that, where I got that from? And I know, let's see, I have 2 electrons left, so I'll go ahead and fill it. Now I'm down to 8 electrons. After my 3s, what comes next? See if you can find it. Don't tell me. See if you can find it, and then we'll talk about it. 3d? No, don't be afraid to tell me no. What comes next, Carson? 3p. So I line it up with my 2p. 1, 2, 3. And I say to myself, do I have 6 electrons left? Yes, I do. So I'm going to fill it up. And then I have to get rid of them up here. Up here. So now I'm down to 2 electrons. And I need to see what I fill next. After 3p, I fill, what do you think, Mary? Follow your arrow. Follow the yellow to fill it. Correct, yeah. And S can hold how many electrons, you guys? 2. And I have 2, so I'm going to fill it up. All of the numbers are represented here. Principal quantum number. Angular momentum quantum number. Magnetic quantum number. Spin quantum number. By looking at this, I can pick out all four of those, and it tells me all the information it can about that electron, where it's located in terms of energy level, sub-level, how it's moving, how many there are, all of those things from this little diagram. I could give you this with no name on it, and you should be able to answer a ton of questions. Now, even maybe try another time. Let's try, maybe we should do one more together before I give you a big one. Let's do zirconium. That's a little bit larger. That's one you don't have memorized. So you're going to have to look at your periodic table. And I think 40 electrons, is that right? Okay. So let's start down here where we know. You guys want to try it by yourself? One thing I need to tell you, and look up here for a second. Remember I had 1s, 2s, 2p? When you get to a 3, it comes up a little bit of, like if I actually had like a 2d, I would have to come up a little and over here. Or a 2f, I would have to come up a little and over here. Okay? I'm going to let you try it. Let's see what yours is. You done? Thank you. What? Pull it down? Oh, I'm sorry. See what you can do with it. When you're all done, or if you're feeling confused, look up front and see if yours looks like mine. I know that it is farther from the nucleus than these other things. So you guys learn it by practice. You learn it by seeing me do it. That's why I talked about how it should be out to the side a little bit more. I had filled my 4S, so I just came up a little, and I knew I had to go past P, so that's what I did. When you look at these, the way I have them written, it kind of tells you the distance from the nucleus of the atom these things are. When you look at that, if you have questions, ask them. I expected these D's to be a little tricky for you because we didn't do one like that. What do you think is going to happen if I have an F? Yeah, it's even going to be out farther. I'm going to have to write smaller. Feel like you sort of got it? Yeah? Yeah, what? D holds 10, yeah. F holds 14. And I'll, probably on Monday, I'll give you one that's really good. I want to show you two other things with this today. And then I'll give you one to practice. So the other things I want to show you are pretty easy, but they use the diagram. So the one we're going to talk about first is called orbital notation. Shorthand. And it's, rather than drawing out all the arrows, it's a shorthand way to write this that tells us what we have. So, I'm going to take this, actually I'll put it on this paper, and I'm going to write an orbital notation shorthand. I'm going to show you how I do this. I start with my lowest energy level and the sublevel that's present, so I start with 1s, and then I look at it and I say, how many electrons are there? Oh, there are 2. And those electrons become a superscript. So I write it as 1s2, and that tells me I'm in the first energy level, the s sublevel, and there are 2 electrons present. And then I move on up in the order of filling, 2s2, 2p, what am I going to put with P? 6, yeah. And then I move on up, 3s2, 3p6, 3d10. I keep my energy levels together. 4s2, I'm going to run out of room. 4p6, 4d2. And then I would put on my 5s2. So that would be shorthand of this big drawing. And I could ask you questions about this too. I could say, hey, what atom is this? I could say, ooh, see if you can answer this one. What is the last energy level and sublevel that has, or that filled with any electrons at all? What's the last energy level and last sublevel that filled with any electrons at all? 4D, good job. Why did you pick 4D? Listen to this, because you're going to have to do it. Why did you pick 4D? It's the farthest one out. What else could you look at in 4D and know? Oh, that has to be the last one that filled. Is it full? No, it's missing electrons. So I know it's the last one that filled. Okay? 5, nope, look at this. 4D is actually above 5s. And that's where the electron cloud, for the question mark, that's where we're talking about that electron cloud where everything starts overlapping. There are points where the 4th energy level is closer to the nucleus than the 5th. And that's, yeah, the 5th is closer to the nucleus than the 4th. Sorry, said that backwards. It fills first. It's closer to the nucleus. Everybody wants to be close to the nucleus. Think about it like that. Think about it like that. The positive stuff's in there. All that negative stuff is attracted to it. So there are times when the 5th energy level is closer to the nucleus than the 4th because of the patterns that those electrons follow. All those weird things I do it. Okay, so how about if you guys try it for calcium? You've got calcium in your notes, we just did it. Remember to keep your energy levels together. Calcium's a little easier. A little shorter, I should say. You got it? It's still working. When you have it, stand up. Now find your lab partner and check with her. I'll just find somebody else to check with. Over there with Lindsay. Or Shelby's right behind you. Check with her. Did you guys agree? Okay, I'm listening. I know we got it right over here. Did it end in 4S2? Okay. All right. Who said no? Do you know what you did? All right, do we need to go over it? Okay. Okay. All right. So now, I'm going to show you. But you got it. Okay, good. All right, I'm going to show you one more thing today. It's called noble gas configuration. And this is even more shorthand than the last one. So let's talk about zirconium, which had 40 electrons. I want you to get your periodic table. I don't think I have one over here. Find zirconium and put your finger on it. Nope, that's not one. There's one. Find zirconium. It is right here. When I do noble gas configuration, I find my element, I hop up a row, and I slide down to my noble gas, which would be krypton. I take that and I put it in brackets, Kr. And then I go, how many electrons does krypton have? 36. I'm going to write that down. So this stuff in brackets represents the first 36 electrons from zirconium. So we don't have to redo all that crap. We don't have to draw all those arrows. We just say, okay, I've already used the first 36. So I pull out my old drawing that we did, and I follow the order of filling, and I get rid of the first 36 electrons. So when I follow my order of filling, and actually put a line through it when you do it, so you can keep track of it. There's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. Here's what I'm left with. So I'd come back over here and I show that. Then I would show 4D2, 5S2. And I can look at this and I can go, okay, this is an atom that has 36 plus 2, 38, plus 2, 40 electrons. Oh, that is zirconium. Okay? Now this is what I want you to do. I want you to get together with your lab partner, and I want you to do all three things: electron configuration, orbital notation, and noble gas configuration notation for, let's do iron and barium, okay? Put one on the front of the paper and one on the back, so you can keep them straight. All right, let's go, see if we can get it done. We've got about 10 minutes. And if you're feeling confused, this is the time to ask me for help. I did follow the order of that. You mean when I wrote it this way? You always write the lower energy level first. Even though this is gold last, it's a lower energy level, so I write it first. I mean, it's lower, these aren't the energy levels, so maybe I can touch energy level. Those are just the order of color. I give you this order first, then second. If you're feeling confused, seriously, ask guys. I don't want you to get to the quiz next week and be like, I don't know what I'm doing. Let me know if you need help.